Good morning, everybody. Welcome to Natural Science. We're doing revision for term 2. We're on grade 8. The topic we're going to revise on is on elements. My name is Arifa Hafichi, and I hope you're going to understand everything I'm going to teach you. If you don't, then please raise your hand or type it in the chat and I will re-explain. Okay, by the end of this lesson, you'd know more about metals, metalloids, and nonmetals. Also, we're going to talk about elements. I'm going to define what an element is. I'm going to list the names of some elements and explain how elements, the composition of elements, how elements are made out of different atoms. Okay, yesterday we learned that atoms are the building blocks of matter, and atoms cannot be divided into smaller particles, nor can they be destroyed by a chemical process. And we also learned that atoms are made up of different kinds of subatomic particles, such as protons, neutrons, and electrons. The central region of the atom is called the nucleus. That is where you would find the positively charged particles called the protons, and also the neutral neutrons that does not have any charge. Now, the negatively charged particles are normally on the energy levels outside the nucleus, and they orbit around the nucleus. Now, and atoms are neutral because the number of negatively charged particles, which are the electrons, are basically equal to the positively charged particles, which are the protons. We also learned yesterday that atoms are made up of 3 different kinds of subatomic particles. And these particles are protons, neutrons, and electrons. The protons are deep inside the zone of the nucleus and they are positively charged, while the neutrons have no charge. They are neutrals. And the electrons, they are the smallest of the 3 particles and they are negatively charged. And these electrons, they are found on each level, energy level, or you can also call them each shell of the nucleus of an atom. Now, atoms are made up of make up elements, and they increase in its atomic number in the periodic table like how I showed you yesterday. So we'll discuss it in greater detail today. So let's see what the characteristics of metals, metalloids, and nonmetals are. Now, one reason the periodic table of the elements is useful is that it means that we arrange the elements according to their similar properties. Like we have metals one side, the metalloids in the middle, and the nonmetals on the far right. Now, this is what is called periodic table trends. Now, there are multiple ways of grouping the elements, but they are commonly divided into the metals, metalloids, and nonmetals. Now, I'm going to give you the characteristics of the metals first. So metals, basically, they're very hard, they're shiny, and they're ductile, and they're malleable. Ductile and malleable means that they can be compressed into flat sheets. So when you make it into flat sheets, they can be made into different substances. Now, also metals have very high melting and boiling points. Now, not the temperature that you would find on your stove, but different temperatures and much higher temperatures and boiling points, because these need to become a liquid and then it's put into a mold and it's given certain shapes like pots, for example. Then they are high thermal and electrical conductivity. That means they're good conductors of electricity. And they form cations. Now, cations are the positively oxidation states. That means like, we did in electrolysis, we put cations and we had anions inside. Now, the cations are positive. They tend to exhibit more than one oxidation state, and they have low ionization energy levels. Then we have the semi-metals. Before I go on to the semi-metals, I want you to look here. So you can see this red part. This red part is all the metals. Then this yellow part is the semi-metals. So they in between metals and non-metals. So sometimes they may take on the characteristics of a metal, and sometimes they may take the characteristics of a non-metal. So the characteristics, um, physical means uh, matter can be separated by physical means. Like, for example, if you're going to separate, Tyrese, you wanted to know. So if you're going to separate by your hand, or you can use a sieve, that means that you can separate matter by physical means. You can physically do it. But you can't do it if you stir sugar in water. You cannot do it by physical means. Okay, I hope that answered your question. Then we have nonmetals. Now, nonmetals, they have high ionization energy levels, they have high electronegativity, and they are basically poor electrical conductors and thermal conductors. They form brittle solids and they are dull. Um, they have little metallic luster. So that's what it means. It is dull by saying it has little metallic luster. And they readily gain electrons. So we say non-metals, they can easily gain electrons. Now, if you have a question, you're welcome to raise your hand, or you can type it in the chat and I will look through it. Now, we also say non-metals are halogens and noble gases, and they have its own group. So metalloids are the smallest class of elements, and it contains 6 elements. So if you look right down at the periodic table here, it's these yellow ones. So these are metalloids. They fall between metals and non-metals in the periodic table. And they have the ability to conduct heat and electricity. And they are shiny like metals, and some of them are not shiny like non-metals. So it depends on which one it is. Now let's look here. Metalloids, they have electronegativity and ionization levels is intermediate. That means that it's not constant, like how you would get it in metals and non-metals. It's not constant, it's intermediate, so it fluctuates. Okay, and then you have um, many possess a metallic cluster. Then you have variable density. Density means that it is put close together, which makes it hard, and its conductivity, that means that it can conduct electricity. And some of them can conduct electricity very well, so we say they are semiconductors. And they have reactivity depends on all the elements in the periodic table. Now, if you look at the semi-metals over here, the pictures of it, it is barium, silicon, germanium, then we have arsenic, antimony, and beryllium. Now, what I want you to do is I want you to look at the following periodic table, and then I'm going to put up some elements here. So we have hydrogen, lithium, sodium, carbon, silicon, magnesium, oxygen, chlorine, potassium, boron, and copper. I want you to tell me what this symbol is for these, and also if they are a metal or a non-metal. You can raise your hand and my host will unmute you, or you can type it in the chat. So helium, what's the symbol for helium? Does anybody know? Helium is a non-metal, very good, Tyrese, and it's H. Robert, well done, Robert. Then we have lithium. What's lithium? The symbol for it. Li, well done, Hawaii. Okay, And then is it a metal or a non-metal? Lithium. It's a metal. Well done. Sodium. What's the symbol for sodium? Sodium is a metal. Well done. So sodium is, sulfur is S. So sodium would be Na. Well done, Erin. Then we have carbon. What's the symbol for carbon? C. Well done. And is that a metal or a non-metal? Is carbon a metal or a non-metal? It's a non-metal. Well done, Jean-Luc and Lasidi. Okay, and we have silicon. Now, silicon, is that a metal or it's Si? Well done. From Hawaii, yeah, I think you're talking from your phone. And is that a metal, a non-metal, or a metalloid? Silicon. It's a metalloid. Well done, Jean-Luc and Helen, and MJ and Hawaii as well. So we have magnesium now. What's the symbol for magnesium? Mg. Well done, Jean-Luc. And is it a metal or a non-metal? It's a metal. Very good, Lucidi. The symbol for oxygen? O, capital letter. Well done, Hawaii. And is that a metal or a non-metal? Nanshlanshla Rabikini, well done. It's a non-metal. Well done, Lucidi. Okay, and chlorine, is that a metal or a non-metal? Chlorine is Cl. Well done, Hawaii. Yes, it is a non-metal. Okay, and potassium. Potassium is a metal or a non-metal? The symbol for potassium, I think it's K, but yes, it is K. Well done, Erin. And it is a metal. Well done. MJ and Jean-Luc and Testodi and Lee Heelan. Now, boron, is that a, what is its symbol? B, well done. And metal or non-metal? Well done, Tyrese, MJ. Nanshla. It is a semi-metal. Excellent. Well done, Tyrese. I tried to catch you out, and Tyrese was very sharp. Even you, Mikon, and Nanshla. And copper. What's the symbol for copper? Symbol for copper, C is carbon, and copper is a metal, and copper is Cu. Okay, Cu. Capital letter C and small letter U. So note that when we're writing the symbols, the first letter is always capitalized, and then the second letter is a small letter. Okay, and we have them being metals, non-metals, and semi-metals, as you have correctly stated. Very proud of you. Well done for that. Okay, so we know that all elements are made up of one kind of element. That means that one kind of atom, forgive me. That means all the atoms are the same. Now, elements cannot be broken down into similar substances. There are 18 known elements, and these are listed in the periodic table. Now, the elements are arranged in order of its increasing atomic number, and the atomic number of the elements is the number of protons of the atoms that occurs in the nucleus. Now, each element has its own name, symbol, and also unique properties. So that's how you can distinguish between an element in a periodic table, because of its name, because of its symbol, and because it is different. It has unique properties. Just like how all of you in the chat, Lasidi, Erin, Nanshlanshla, MJ, Helen, you are all different from each other. So you have the elements in the periodic table, they are also all different, having their own names, their own symbols, and their own unique properties. So some elements consist of single atoms that are bonded together to form a unit. And these are called diatomic molecules. This means that it consists of two identical atoms. And atoms of different elements uh, are different. They have different number of protons, neutrons, and electrons. So you won't have two atoms that have exactly the same amount of protons, two elements, sorry, you won't have two elements that have the same number of protons, neutrons, and electrons, because then it would be the same. For example, you won't find two of me exactly like me. So even if I was an identical twin, I'd be a little bit different in some way. So this is what makes elements different. So here's a picture of a carbon atom. In the nucleus, you'll see the protons and the neutrons, and you'll see the negative electrons orbiting around in each energy level around the nucleus. So an electron is negative, a proton is positive, and a neutron is 0. Okay, so now basically matter is made up of a solid, a liquid, and a gas. And matter, atoms are basically the building blocks of matter. And atoms make up elements. A combination of atoms are basically called a molecule. And molecules that are similar in nature make up elements, and molecules that are different in nature make up compounds. Yes, the center of the atom is called the nucleus. Well done, Tyrese. You're also welcome to raise your hand, because I'd also love to hear you, and it will make the lesson also more interesting. So we have hydrogen. I actually don't know how many atoms in the human body, because if there's 1 trillion atoms in a small grain of salt, can you imagine how many atoms would be in the human body? Because you have your lungs, you have your heart, you have all your different organs, you have your skin, you have your blood vessels, and all these are made up of atoms. So it would go into a number that you cannot understand. Okay. Okay, now look at these hydrogen atoms. So it's 1 proton, 1 electron. So a carbon is 6 protons and 6 electrons. Oxygen is 8 protons and 8 electrons. And nitrogen is 7 protons and 7 electrons. So you can see that each element here, in the hydrogen, carbon, nitrogen, and oxygen, they are composed differently. So it has different amounts of protons and electrons, and basically that's what it gives us its name or its state. So let's do a checkpoint. I'm going to ask you a question, and you can answer. You can raise your hand. Or what does an element look like on an atomic level? Does anybody know? And also, what table summarizes in an orderly way all the elements known to us? So if you want to type it, then you can write A, what the answer is, or B, what the answer is, or you can raise your hand and my host will unmute you. What does an element look like at an atomic level? Okay, 2 is the periodic table. Well done. That came from Hawaii, from his phone or her phone. Okay, so basically the atoms of an element all look the same. So what I wanted you to understand is, because I've been repeating it quite a few times, is that Aviwe, you have you'd like to speak. I'll ask my host to unmute you. Aviwe. Okay, so do you want to tell me, Aviwe?
Hello, ma'am.
Hi, I can hear you.
Yes, ma'am.
What answer do you want to give? B.
Can you hear me, man?
I can.
Uh, I want to answer B.
Okay,
I want
what's
to
the
answer
answer?
B, man.
Okay,
A table which summarizes all. It's a periodic table, man.
it's a periodic table. Well done. Thank you for that. Okay, thank you, Abiwe. Okay, so we have the table that summarizes all the known elements is the periodic table. So now, if you have this question, what does an element look like at an atomic level? Then your answer would be that all the atoms in the element would look the same. That's basically what makes up an element because you have the same atoms. Okay, so you have atoms and elements. All the elements are made up of very tiny particles called atoms, and the center of the atom is called the nucleus, where you find the protons, and the electrons spin around the nucleus in energy levels. So the question that they have here is, what particles are found in the nucleus? So we know it is the protons. And then what particles are found in the energy levels around the nucleus? We know it is the electrons. So these are different ways that they can ask you in a test, and you need to be able to answer them or know how to answer them. So an atom of a specific element are identical. For example, the element sulfur, it consists only of sulfur atoms. Then we have um, when an element consists of diatomic molecules, the atoms of that molecule are identical. For example, the atoms of diatomic molecules of chlorine have both chlorine atoms. Now, there are 7 diatomic molecules, and you can learn this very well. You can write it down if you have a page or pen with you, or you can screenshot it if you have your phone. So the diatomic molecules are nitrogen. Can you see it's N2? Hydrogen, which is H2. Oxygen, which is O2. And these twos actually should be small twos at the bottom. Fluorine, which is F2. Chlorine, which is Cl2. And iodine, which is I and a 2 at the bottom. And we also have bromine, which is Br2. So basically, these are diatomic molecules. And this is the names of them. So it's nitrogen, hydrogen, oxygen, fluorine, chlorine, iodine, and bromine. And you need to understand that these cannot exist on their own. They need two atoms that are bonded together to form these. They cannot exist purely on its own. Now, each element has its own particular symbol and its own unique properties. For example, the symbol of sulfur is S, and sulfur is yellow, and it is a non-metal powder. Okay. Now, scientists all over the world uses the same symbols of the elements that are listed in the periodic table. Now, it's not only like in South Africa they use that symbol, it is all over the world. Now, you might think that they are different because there are so many materials in the world and there may be millions of different elements. However, all elements are made up of a small number. All material basically is made up of a small number of elements. So you have, it's just a small number, like how you make a cake. You'll take flour, you'll take sugar, you'll take eggs, you'll and butter or oil if you're going to use. So you're taking a whole lot of different things and you're putting it together to make a cake. And this is the same with an element. So you're taking a composition of the same atoms and you're putting it together to make specific elements. Now there are 118 known elements. of which 93 elements occur naturally. So that means it is found in nature on its own. Okay, and then while 25 elements are made by scientists in it is made in laboratories. So the other 25 elements, man has made them, and these are made in laboratories. So elements are arranged in the periodic table according to their atomic numbers, which are the numbers of the protons in the nucleus. So you need to understand this. The elements are arranged in their atomic numbers. That means that if the atomic number is growing, it has more protons and more electrons. So we know that how elements are arranged. It grows according to its atomic number. Now, the first element is hydrogen, because hydrogen, I just want to notice, hydrogen has one proton in its nucleus. So hydrogen has an atomic number of 1 because it has one proton in its nucleus. Okay, so I have basically a list of here to show you how elements are arranged. So we took the first few according to their atomic numbers, the first 20, which you should know and learn by heart. Okay, and these are the symbols. So these are the number of electrons that float around the shell of each shell. So this is the atomic number of each element. It goes down 1 to 20. Now in the first shell, except for hydrogen, there's always 2 electrons. And then you get the second shell and the third shell. And this is how the composition of it. And it's calculated through a formula, electronic configuration formula. So here it is in the periodic table, the first 20, it's listed on the right-hand side. And then on the left-hand side, we put it in a table form for you, where you have the first 20, then its symbol, and we have the number of electrons that has it. So if the number of electrons are this, then the number of protons would be equal to the number of electrons. So I'm going to move on to molecules and explain what molecules are in greater detail. Now, the cluster of atoms in the previous example are called molecules. Now, molecules is a very important word in chemistry because it has 2 or more atoms that have chemically bonded with each other. Now, the atoms in a molecule can be of the same kind, in which case it would be a molecule of an element, or they can be different kinds. Not all the elements have molecules. I think Nanshlanshla wanted to know where you would find potassium. Now, potassium is a symbol K, and if I go back to this, potassium is basically the 19th element. So you'd find it here on the periodic table. So it's the first, second, third, fourth. It's the 4th row. Okay, I hope that answered your question, Nanshlanshla. So the atoms in you're welcome. The atoms in a molecule can be the same kind, in which case it would be a molecule of an element, or they can be of different kinds, in which case it would be a molecule of a compound. Now, not all elements have molecules. The elements on the left-hand side and the middle part of the periodic table are solids at room temperature, so they exist as tightly packed arrays of atoms like the previous examples or of silver and copper. Now, molecules of many nonmetals on the right side of the periodic table are gases at room temperature that exist as molecules made up of 2 atoms. Now, these are called diatomic molecules. Now, the picture of an element that we discussed earlier shows a diatomic molecule, which is oxygen, nitrogen, chlorine, and some other elements of nonmetals, they form diatomic molecules. Now, there is somebody that wanted to know what a symbol of, um, let me just try to find it, of what is a sulfur hydroxyfluoride element is. Okay, so that I will discuss with you in our next lesson. So I'm going to summarize. We have subatomic particles. There are three subatomic particles that exist in a structure of an atom, which is a proton, a neutron, and an electron. So protons are positively charged and are found in a nucleus deep in the center of an ion. And neutrons are similar to protons in size and mass, but they do not carry any charge. They are neutral and they are found in an atomic nucleus. So Tyrese wanted to know, can we combine different compounds together? Now, compounds is my next lesson, which is going to be tomorrow, which is where I'm going to show you how you take different elements and you put it together and they found compounds. Okay, so that would be my next lesson tomorrow, Tyrese. So now electrons are similar to protons in size and mass, but they do not carry any charge. They are neutral. They are found in a nucleus, atomic nucleus. I believe one person wants to ask me a question. Tashidi, I'll ask my host to unmute you. Okay, while you're getting unmuted, I'm going to continue. We have electrons are negatively charged particles. They're much smaller than protons and neutrons. And there's a cloud that moves around the electron very fast. There's a cloud that moves around the nucleus very fast. And this is caused because the electrons move around. Now, in a neutral atom, the number of protons always equals the number of electrons. Hence, the atoms are neutral. Now, all matter can be classified as mixtures of substances or pure substances. And pure substances can be classified as elements or compounds. And I'm going to discuss how compounds are made in our lesson tomorrow. Now, all elements in an atom are the same kind, and this means that an element cannot be changed into any other element by a physical or a chemical process. Now, elements are up, built up of individual atoms or as bonded pairs of atoms called diatomic molecules. And when elements combine, they are called compounds. So, like when you have two elements combining through heating or through some chemical reaction or chemical process, this is called a compound. They form compounds. Okay, all the information that was derived was from sayavela.com and nect.org and the Department of, and I also used thought.com to get some information about periodic tables to help you understand. If you'd like to contact me or if you'd like my slides, I'll give you my email. But our next lesson tomorrow is on compounds, and I'll be very happy to answer any question that you have. I have one question. If what I can do tomorrow is because we are finishing early, I did basically why we're finishing early as opposed to when we have finished later in previous lessons is because I condensed the sections to give you a more comprehensive knowledge, a foundational knowledge. I can increase the information if you want me to go at a faster pace, but I do remember that when I was teaching this section initially, you guys wanted me to go at a slower pace, which is why I went slowly now to give you a foundational knowledge. Okay, you're very welcome. Um, you can contact me at ahaffea@gmail.com if you would like my slides, or if you want any other information. I did have a lovely time tutoring you. I hope you benefited and enjoyed the lesson, and I'll see you here tomorrow. Goodbye, everybody, and have a lovely day. Bye, everybody. You are welcome.